Hello everyone, I'm Shelly Bhardwaj and this is my project CyberShield AI, built for the Agent for Good track in Kaggle's 5-day AI agent program. A lot of students get trucked online, fake internship, fake scholarship, phishing emails, and fake job offers are everywhere. Scammer ask for a small fee or send fake login pages that look real. Students, especially freshers looking for job, are these target. CyberShield AI checks a message, a link, or a job offer and tells the student if it's safe or not before they trust it. Let's start with the home page. This is our landing page where student can learn about common threat and vectors or jump straight into testing using sandbox mode. To sign in instantly with the guest token, or we can simply log in through my student credentials. You can register here. Once you register, you can log in. Now we are on the main dashboard. The first tab is Safety Check. Here you can paste any message or link. For this demo, I will paste a fake remote job or message. You can simply click Try an example. And after that, you can click Check for Safety option to analyze it. As the audit runs, we are directed to Safety Review tab. Look at the generated report at the top. We get a clean, highly fidelity verdict stating whether the message is safe, suspicious, or dangerous. Next to it, a circular score. Circular gauge displays a safety score out of 100. Down below, the Safe Next Step card provides action advice and even generates a professional safe reply template that student can copy to decline the offer safely. Before diving into the agent detail, let's explore other tabs. Here is the Safety History tab. It acts as a personal secure vault, listing every scan the user has performed. You can search your history by keyword or case ID. And the safety score displayed here are aligned perfectly with the main result curves. Next, we have the community trend. This displays aggregate matrices of scams analyzed across the campus. And finally, the Safety Hub acts as a learning space with security tips and interactive guide to teach how to spot phishing indicators. Now let's look at the technical core of the project, the agent execution roadmap, which shows how the system made its decision instead of asking one AI model to guess everything. CyberShield AI splits the work across 7 agents using Google's Agent Development Kit. When a message is scanned, it goes from the user input node to the supervisor. The supervisor coordinates the scan, running 5 specialized checking agents in parallel. The message analyst, checking for urgency. The link verifier, validating URLs. The placement auditor, auditing job details. The OCR scanner, reading images and text from PDF. Intel correlator, matching threat records. Once the check complete, the safe responder compiles the advice and the DB archiver stores it. The border of Border color on the map are fully dynamic. Orange represent processing nodes, green represent saved database, and red represent up on any checker agent and detects a threat. Like the message analyst flagging a score of out of 100. For total transparency, we can expand the technical details drawer. Below the map, this pulls up the exact observability traces showing timestamps, execution, and log. You can simply print here to generate a report. So this is all about the project. I built CyberShield AI using Google ADK, Gemini, Fast API, Python, SQLite, Docker, and hosted on Render. In the future, I plan to add a browser extension to auto scan portals and share threat data across universities. CyberShield AI shows how specialized AI agents can work together to solve real world problems and explain their answer clearly. Thank you for watching, and I hope CyberShield AI demonstrate how multi-agent systems can be used to solve meaningful real-world cybersecurity problems. Thank you.